Hello again, this Michael lecture is on gravitational potential energy. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms. Now, before we talk about what gravitational potential energy is, let's talk about the word potential. So potential is a future possibility, something that could happen but hasn't happened yet. Oftentimes we'll say somebody has a lot of potential, or something has a lot of potential if it's something that could be very successful or rewarding in the future, but it's not there yet, so it still has kind of a ways to go, or maybe it's going to happen tomorrow. But it's something that could happen under the right conditions. So if we talk about potential energy in general, we're talking about energy that really hasn't shown itself yet. It's stored energy. It's energy that's kind of hidden away, and it's usually based on something's position or height or distance away from whatever might give it energy in the future. So, for example, if you take two magnets and you separate them, then what we have are two things that are either pulling on each other or pushing on each other to separate, either repel or attract. But based on that separation, there is energy that can be released by letting go of those magnets. They'll either attract in this picture, or in other times it might be repelling. So again, we've got this idea that energy is stored. Another way would be if we are storing energy in a spring or something that behaves like a spring. We can push a block in, and right here it may not be moving, so it may not have any kinetic energy or other types of energies that we're looking at, but it could have that energy as soon as we release it. So the spring has some stored energy in it. And so this is usually based on either compression, squishing a spring, or stretching a spring, also stores energy in it. Which brings us to the one we're going to be talking about the most, which is gravitational potential energy. Sometimes it's just called potential energy because it's the most common one we deal with, but that's really just because people don't like saying the word gravitational all the time. Sorry about that. So gravitational potential energy is stored energy, and it's based on something's distance from Earth, or really any other source of gravity. So in this case, this roller coaster has gravitational potential energy simply because it is high above the ground, and so as soon as you kind of let it go, it's going to pick up kinetic energy. So Earth's gravity field is going to pull on it and give it more energy, or give it kinetic energy in this case. So that's why we say it has gravitational potential energy when it's up high above the Earth. Now, to calculate gravitational potential energy, you do mass times gravity times your change in height. So really you're just focusing on how much could the height change or how much did the height change, and that's what you'll reference. So, and as always, energy, including gravitational potential energy, is a scalar, so direction doesn't really matter. That being said, you'll sometimes see positive and negative values for energies simply when you're adding or subtracting energy away from something. And like before, I mentioned it's measured in joules. Alright, let's practice graphing it real fast just so we can see what the relationship between gravitational potential energy and height is. So if we have mgh, or mg delta h, as our formula in this case, and we're lifting something from 0 meters to a height of 5 meters, and it has a mass of 2 kilograms, then when it starts at 0, it still hasn't changed its height, so the change in gravitational potential energy is still 0. However, after 1 meter, it will have gained 20 joules of potential energy. After 2 meters, it will have gained 40 joules of gravitational potential energy. After 3, 60, after 4, 80, and after 5, 100. And so we can see that this is a linear relationship between gravitational potential energy and our change in height over here. So, like I said, it's a linear relationship between gravitational potential energy and change in height. It's also a linear relationship between gravitational potential energy and mass. You could think of it as a linear relationship between it and gravity, but we don't tend to change gravity in like incremental values like that. It's usually a more complicated scenario. Now, one last thing, which is this unit is about the idea of mechanical energy. So mechanical energy, what I want to tell you is it's the sum of all potential and kinetic energies. Now, we've focused on gravitational potential energy, but another one that I mentioned was elastic potential energy. There's other ones out there like rotational kinetic energy and things along those lines. But if you sum all of these potential energies up that deal with things that are springy or gravity, not so much magnetism, then we call this mechanical energy. And so it's a general term for kind of the total amount of potential and kinetic energies. because later on we'll see that potential energy can turn into kinetic, so sometimes it's useful to think about them together or the total amount of it. That's it for this one, 3 or more bullet points worth of notes, so 1 to 2 sentence summary, and please do your follow-up questions on Google Forms.